Houston, Texas, the country's fourth most populous city, is in peril. Houston has always been vulnerable to killer hurricanes. From the Great Storm of 1900, the deadliest in U.S. history, which killed 8,000 people, to Hurricane Ike in 2008, which caused nearly $10 billion in damage and forced the city center to shut down for nearly a week. And it's not only hurricanes. Searing heat and humidity also oppress this great city. On nearly 100 days each year, the temperature climbs above 90 degrees, which in muggy Houston feels even hotter. Air conditioning provides relief, but at a cost. Houstonians' soaring electricity use has nudged the city ahead of Los Angeles in the race to become the country's #1 producer of greenhouse gases. A dubious distinction. And the problem is only getting worse. Forced to spend a fortune in a losing battle against nature, and with energy costs spiking unpredictably, Houston finds itself square in the path of an environmental juggernaut, which threatens to make the city unlivable. That's why some think that the only way to save Houston is to move it indoors. The Houston Dome's surface area will stretch over 21 million square feet, making it the biggest structure with the largest roof in the world. The dome's broadest panels will be 15 feet across, with over 147,000 of them covering the city of Houston. Imagine the nightmare of trying to fill those panels with traditional building materials.
A dome of this size could not be done with conventional materials. If we have to do this in glass or plexiglass or any other of that type, it'll be so heavy that we simply could not build it.
The Houston Dome's panels require something much lighter. Here, in the small German city of Bremen, this factory, the main headquarters of the Vector Foil Tech company, is at the epicenter of a revolution in material science. The company manufactures Etilene Tetra Fluoro Etilene, or ETFE. It's an incredibly strong yet lightweight and transparent polymer that's changing the face of modern architecture.
Anything that people thought about 20 years ago was based on glass, and it was limited to the technologies of glass. Nowadays, ETFE has basically opened the minds of architects and engineers to completely new horizons.
ETFE is the breakthrough that will finally make Fuller's city-sized dome possible. One of the German company's biggest commissions was the Eden project. More recently, ETFE was used to create the beautiful bubble-like exterior of the Beijing water cube. At just 1% the weight of glass, ETFE is described as 99% nothing. It makes possible a surface-to-weight ratio that Buckminster Fuller could only have dreamt of. Without it, the Houston Dome could never become a reality.
It is so light, 99% lighter than glass. I mean, that's tremendous.
One strip of ETFE is strong, but 3 layers are even tougher. Not only that, but the cushions can be inflated to create aerodynamic shapes that react to shifting wind loads. Engineers routinely subject ETFE to a series of punishing tests. Wind forces will subject the ETFE to tensile or stretching stresses. To test this batch, technicians suspend 551-pound weights from a piece of ETFE. To pass, the ETFE should slowly stretch, but not tear. But the Huston Dome has a further problem. Here, life must continue as construction takes place overhead. Holding up the dome from below with scaffolding is impossible. So Huston will take the opposite approach.
One idea that's been floating around is to have this army of dirigibles that are capable of staying in place for a long period of time.
Airships hovering over a city recall an earlier era. But a ship like the Zeppelin NT could also be the future. Airships may be lighter than air, but they are also incredibly strong. And today, safe. The hydrogen that filled the Hindenburg was treacherous. But these ships are filled with helium, an inert gas that cannot burn. One of these fuel-efficient ships can stay aloft for hours. And carry a 4,100-pound payload. An army of next-generation ships could take the place of cranes to hold the Huston Dome erect as it nears completion. It will require planning, coordination, and an intricately choreographed delivery schedule.
You've got a colossal amount of materials that you're going to be using, obviously significantly more to achieve what you're talking about. It's going to have to be programmed so carefully, every single detail, to ensure that it all runs sort of smoothly.
One false move could spell disaster. Unless builders deploy the world's largest safety net as a final measure of protection. After years of construction, after billions of dollars spent, the Huston Dome faces its biggest test.
We need to consider protection against extreme weather events. And I'm talking about hurricanes.
A Category 5 hurricane can flatten a city. And when such a storm eventually bears down on Huston, the geodesic dome's most beautiful design features, the sleek steel struts, the lightweight plastic panels, and the absence of interfering interior support columns, may lead residents to ask, will this delicate-looking structure be strong enough to stand up to Mother Nature's worst? Against a powerful hurricane, the Huston Dome has several lines of defense. The first comes from its skin.
High winds for ETFE cladding systems not a problem at all, due to the material being extremely elastic and forgiving. They cope with basically any type of wind load if designed correctly.
ETFE can withstand winds of 180 miles per hour, a higher velocity than even the strongest Category 5 hurricane. The pillows have an added layer of protection.
It has an exterior layer, an inner layer, and an interior layer. As long as you can keep one of them, the whole skin of the dome still remains intact.
Even if a panel ripped wide open, the rest of the dome's steel frame would be ready to bear the burden. But the panel's ability to resist the buffeting winds is only the beginning. Behind them stands a second line of defense,
mega structure of the kind that we're talking about for Houston, Texas, first of all, we have to realize that it's a space frame, which is a three-way grid.
The space frame, relying on the inherent stability of the triangle, provides a counterforce equal to any external wind load.
So now we have a very strong triangulated spherical structure, and it will not be vulnerable to the toughest hurricanes that we've ever experienced.